Welcome to The Explainer. Today, we're diving into the absolute core of macroeconomic theory. Have you ever wondered if human behavior, specifically, our spending and saving habits, can actually be mathematically mapped out? Well, today I'm going to completely demystify the Keynesian model of income and employment for you. We're going to look at the exact formulas economists use to predict precisely what we do with our money. It's an incredibly elegant system, and by the end of this, you're going to see the economy through a totally different lens.
But before we jump into the math, I've got a fundamental question for you. Imagine your income just suddenly vanishes. It hits exactly zero. What happens to your spending? Do you just stop spending entirely? Take a second to really think about that baseline reality of economic survival. If you earn nothing, do you actually spend nothing? Keep your answer in the back of your mind, because the mathematical reality of this very question is the bedrock of our whole model today.
Here's our roadmap for today. We'll start by explaining the consumption function, then compare total habits to incremental changes, look at the flip side, which is saving, and finally wrap it all up with the mathematical unity of the whole system.
All right, let's dive right into Section 1, the consumption function explained.
At its core, the Keynesian consumption function is a brilliantly simple concept. It represents the functional relationship between desired consumption expenditure and income. Symbolically, we write this as C equals F of Y. So in the most basic terms, this equation is just telling us that how much you spend, represented by that big C, is a direct function of how much you make, represented by Y. Your spending doesn't just happen in a vacuum, right? It's completely anchored to your income.
Now, this functional relationship is governed by three unbending rules. First, there's a direct relationship. As your income goes up, your planned consumption goes up too. Second, what we call the marginal propensity to consume sits strictly between 0 and 1. And third, the average propensity to consume actually decreases as your income goes up. Basically, the richer you get, the smaller the fraction of your total income you spend. Make sense?
And this brings us right back to that opening question. In economic modeling, even when your income is strictly zero, your consumption doesn't drop to zero. We call this autonomous consumption, represented mathematically as the intercept, A. Because think about it, even at zero income, you still have to eat to survive, right? You'll dip into past savings or borrow money just to make that mandatory survival spending happen, completely independent of whatever your current income is.
Moving on to Section 2, total habits versus incremental changes.
To really grasp this, let's look at things side by side. On one hand, we measure total habits using the average propensity to consume, or APC. This is the overall proportion of your total income that gets devoted to consumption. On the other hand, we measure incremental changes using the marginal propensity to consume, or MPC. This looks at how you behave when handed just a little extra cash. So APC looks at the big picture, while MPC looks at what happens right at the margin. Let's anchor this with a super concrete example. Imagine an economy in its initial state where total income, or Y, is 1,000 crore rupees. And out of that, total consumption, C, is 900 crore rupees. To find the APC, we just divide that 900 by the 1,000. So our average propensity to consume is 0.9. This means that, on average, society is spending exactly 90% of its total income.
But remember that third property of our consumption function we just talked about? APC doesn't stay static. As income rises, the APC actually declines continuously. Think about it. As you become wealthier, your basic survival needs are easily met, so the proportion of your total income that you absolutely must spend on consumption drops. The ultra-rich spend a much smaller overall fraction of their total wealth than lower-income earners do.
Now let's look at the incremental change. Suppose total income in our economy increases from 1,000 crore to 1,100 crore. That's a bump in income of positive 100 crore rupees. As a consequence, let's say consumption rises from 900 to 980. Our change in consumption is positive 80 crore. We divide that change in consumption by the change in income, 80 divided by 100, and boom, we get an MPC of 0.8. Out of the new extra income, 80% of it was spent.
So the crucial takeaway here is this ironclad mathematical rule. The marginal propensity to consume must always sit between 0 and 1. When your income goes up, your consumption goes up too, so MPC is definitely greater than 0. But it goes up by a somewhat smaller amount than the income increase itself, because, well, a part of that new income gets saved. You spend some, but fortunately for your bank account, you don't spend all of your new wealth.
Which leads us perfectly into Section 3, the flip side, which is saving.
Now we're looking at the exact mirror image of spending.
First, we have the average propensity to save, or APS. This is the proportion of total income that households want to save, calculated as total savings divided by total income. Next to it, the marginal propensity to save, or MPS. This is the ratio of the change in saving to the change in income. The mechanics here are perfectly parallel to what we just learned about consumption. It's like two sides of the same coin.
Returning to our initial example, total income was 1,000 crore rupees. We knew consumption was 900, which logically leaves exactly 100 crore rupees as total saving. If we divide that 100 crore of saving by the 1,000 crore of income, we get an APS of 0.1. In other words, exactly 10% of the total income in this economy is being safely tucked away into savings.
And what about on the margin? When income incrementally jumped by 100 crore rupees, we saw consumption eat up 80 crore of that. That leaves 20 crore rupees of brand new saving. Divide that 20 by the 100 crore change in income, and we arrive at an MPS of 0.2. For every single new unit of income, 20% is being saved.
All right, let's bring it all together in Section 4, the mathematical unity. Everything we've discussed today rests on one fundamental absolute truth in the Keynesian model. Income can only be spent on consumption, or it can be saved. There is literally no third option. Therefore, consumption plus saving perfectly equals total income. C plus S equals Y. This isn't just some abstract equation, it is the absolute boundary of our economic reality.
Let's prove just how elegant this system is algebraically. Step 1, we start with our fundamental truth. C plus S equals Y. Step 2, we divide every single term on both sides by Y. We get C over Y plus S over Y equals Y over Y. Now think back to the definitions we just learned. C over Y is our average propensity to consume. S over Y is our average propensity to save. And Y divided by itself is simply 1. And this brilliantly illustrates our third step. APC plus APS must always equal exactly 1. Exactly 1. It's just a deeply satisfying, absolute mathematical unity. I absolutely love how clean this is. The sum of the average propensity to consume and the average propensity to save is always exactly 1, at all levels of income. If you find out a society is consuming 90% of its total income, you don't need to do any complex research to find its savings rate. You know with absolute mathematical certainty that they are saving exactly 10%.
And you know what? This identical logic applies perfectly to the margins, too. Step 1. Any change in consumption plus any change in saving must perfectly equal the total change in income. Step 2. Divide everything by the change in income. What do we get? Step 3. The marginal propensity to consume plus the marginal propensity to save equals exactly 1. Every single new dollar, euro, or rupee introduced to an individual is perfectly split between additional spending and additional saving. Together, they always form unity.
Before we wrap up, let's really lock in our core takeaways. First, autonomous consumption guarantees that spending exists even when income is zero, because basic survival mandates it. Second, we have to always distinguish between total habits, our APC, and incremental habits, our MPC. Third, saving is literally nothing more than the strict mathematical mirror of consumption. And finally, because income can only be spent or saved, these propensities will always, flawlessly add up to 1.
Now I want to leave you with one final provocative thought. We know that MPC and MPS always equal 1. So what would happen to an entire macroeconomic system if every single person suddenly panicked, stopped spending, and increased their marginal propensity to save to nearly 1? I mean, if no one is consuming, what happens to the businesses producing the goods? Think about the massive chain reaction that would cause. Thanks so much for joining this explainer. I hope this has totally transformed how you visualize income and spending. Keep looking for the math in the world around you.